Hi everyone. Now we are going to discuss about another one transistor circuit. Here we are considering current in beta as a 50 and the saturation current between the collector and the base ICBO is equal to 27 microamps. Let us consider the saturation voltage VC sat as 0.1 volt and we are going to apply the 5 volt to the base terminal of the transistor. And here we have to find the collector current IC sat and operating region of the transistor. Initially, we have to find the saturation current IC sat, which is equal to VCC minus VC sat collector resistor RC, which is equal to 10 volt minus 0.1 volt divided by 1 kilo ohm, and which is equal to 9.9 milliamps. This is the maximum collector current which can flow through the transistor, and we will assume the transistor operating in active region. So we have to find the base current IB. Actually, this is the base current IB, and we have to consider this as I1 and this as I2. And here we are assuming the transistor operating in active region, so that by considering the current transistor base to emitter voltage VBE 0.813 volt. If we apply the KCL rule, I1 is equal to IB plus I2. That means IB is equal to I1 minus I2. And here we are considering V in as 5 volt. So that current I1 is equal to 5 volt minus 0.813 volt divided by 22 kilo ohm, which is equal to 0.19 milliamps. Here, the emitter terminal of the transistor is connected to the ground, so that we can consider voltage at this node as VB, which is equal to 0.813 volt. So that I2 is equal to VB minus of 10 volt divided by 220 kilo ohm, which is equal to 0.813 volt plus 10 volt divided by 220 kilo ohm, which is equal to 0.049 milliamps. So that the current IB is equal to I1 minus I2, which is equal to 0.19 milliamps minus 0.049 milliamps, and which is equal to 0.141 milliamps. Here, the value of the current IB is positive, so that the transistor never go into the cutoff region. Let us find the collector current IC. Beta into IB plus beta plus 1 into ICBO. Usually in the transistor, the saturation current ICBO is in the range of nanoampere, but here we have considered the saturation current as 27 microamps, so that we have to consider this ICBO also in the calculation. So that collector current IC is equal to 50 into 0.141 milliamps plus 51 into 0.027 milliamps, which is equal to 7.05 plus 1.38, which is equal to 8.34 milliamps. Here collector saturation current IC sat is equal to 9.9 milliamps, and collector current IC is equal to 8.43 milliamps. As we see here, the collector current IC is lesser than the collector saturation current IC sat. So that we can conclude that this transistor circuit operating in the active region. When I run this circuit, we can see the collector current IC is around 9.8 milliamps. Base current IB is equal to 0.198 milliamps. So we can tell that this transistor circuit operating in active region. Hope you have understand how to calculate the collector current when we have the collector to base saturation current as bit higher compared to the normal transistor. And we know that how you confirm the transistor operating region, whether it is working in active region or saturation region or the cutoff region. I request you to kindly subscribe and like the video. Thank you for the watching.